Now we go from area to volume. Volume is a three-dimensional idea. Notice 1, 2, 3 measurements: length, width, and height. Length, width, and height. So this is a rectangular prism. And if you want to find its volume, its capacity to hold, right? How much things can be holding. It could be liquid, solids, air, whatever. This would be the formula. Just plug those numbers in here and you get your volume, and it's going to be to the third power, the units. Converting units to measure. Notice, how would you convert 5 cubic meters, excuse me, to cubic centimeters? So from cubic meters to cubic centimeters. You don't go directly to the cubic meters. You have to go back to the length relationship. 1 meter equals 100 centimeters. After you know this connection, all you have to do is raise it to the power you need. If you raise it to the third power, you're going to have volume. If you were to raise it to the second power, you would have area. So you raise this to the third and this to the third. So there's 1 cubic meter. And this would be 100 to the third, 100 times 100 times 100. So this is 1 million cubic centimeters. 1 cubic meter is equivalent to 1 million cubic centimeters. Notice once you have that conversion, this is like a scale factor, conversion factor. You draw your box diagram, put this relationship here, put this one in the bottom so you could cancel the cubic meters. This is where you're going. So now you have 5 cubic meters equals 1 million cubic centimeters. This one is a formula for the volume of a prism. Notice that this prism is kind of slant. It's called an oblique prism. When you see it kind of slant, it's kind of slant, you don't say right prism, it's an oblique, it's slanted. Either way, you could use this formula, whether it's a right prism or an oblique prism. This is a formula, remember, excuse me, a capital B represents the area of the base. So whatever this base is, this happens to be a rectangle this time. Then we have the volume of a cylinder. Notice that pi r squared, that reminds us of the area of a circle. So the area of a circle times its height. This would be its height. Right here we have the volume of pyramids and cones. The reason we have them lined up like this, it's because there's a special relationship. Notice I broke it up into 2 parts. Notice how these look. BH, 1/3 BH, BH, 1/3 BH. If you had a hands-on activity and these were figures you had, you could put water in here, fill this with water, and since this is 1/3 of this, you could fill it with 3 of these. 3 of these filled with water would fill 1 of these. So this one would be the V equals BH, and this is a third. 3 of these makes 1 of these. One way you could remember, this is a rectangular prism. Notice it's a right prism, rectangle because the base is a rectangle. Right prism is connected to a right pyramid. Notice prism starts with a P, pyramid starts with a P. It's a way to remember, a memory device, a mnemonic. Look at this one. You could put 3 of these in here, fill this with water, and 3 of these would fit in here. Notice the formulas. How can you remember these are the ones that are connected? Well, right circular cylinder, right circular cone, both of these have a C. So these C's go together and these P's go together. The volume of a sphere is very easy. Notice this one has to the 3rd power. The area was just 4 pi r squared, but the volume is 4/3 r to the 3rd. If you know the radius of the sphere, just plug it in here, simplify, you have the volume of the sphere. This next idea is very interesting. It could save you a lot of work. A scale factor. Remember, a scale factor. A factor is something multiplied. In other words, if you multiply the size of 1 times visualize a change in length, area, multiply, unless you multiply it times 1, you just make a copy of the same. But usually other numbers multiply times small. So if you have the linear dimension changed by a factor of k, so if you have a scale factor of k, the linear dimension, for example, the perimeter, the radius, the circumference, so that would be the k measure. Now, if you have, once you have that k measurement, suppose you increase the radius by 2. Okay, so the scale factor will be 2, right? If you want to find out how much area surface area has changed, just get that 2 and square it, and that would be 4. So if you change the radius from 1 to 2, the surface area is going to quadruple 2 to the second. And the volume is going to be cubed. So if this was a 2, the radius is a 2. So if you double the radius, the volume will be raised to the 3rd power. This is another interesting thing. It was kind of weird because you have a centimeter, a milliliter, and a gram. You say, how can these be related? And they're related. If you have your rectangular polyhedron here, notice that this is a centimeter, this is a centimeter, this is a centimeter. So it's centimeter times centimeter times centimeter. The volume of this three-dimensional figure is 1 centimeter cubed, right? Well, if you were to fill it in with water, you would be able to fill it in with 1 milliliter of water. So this will hold 1 milliliter. And not only that, if you were to weigh this, it would weigh 1 gram. Another interesting equivalence is that 1 liter, which represents what liquid, 1 liter weighs 1 kilogram. They're equivalent. These are equivalent. These are equivalent.